In this lesson, we're going to take a look at how we collect and analyze data and how we can put it together to get information from it. So not only are we going to look at how to build a nice data table, but then we're going to look at how we put together graphs. But of course, the very first thing we have to do when we're analyzing data is get some data, and that means we're making measurements. And when you make a measurement, you want it to be both precise and accurate. Now, precise means how exact your measurement is, how many divisions you're measuring to. And this depends sort of on what instrument you're using. You can't just get more precise by estimating. You actually have to get a higher quality instrument. So if you have a ruler that's divided by centimeters, then you can measure to the nearest half centimeter because you can estimate in between. But if you have a ruler that's divided in millimeters, then you can measure to the closest half millimeter because you've got more divisions, and so you can be more precise, you can be more exact with your answer. So the number of decimals that follow your answer, the number of divisions that you have, that determines how precise you can be. So 1.2 is less precise than 1.3 or 1.23 because here we're measuring to tenths and then hundredths of grams, while here we're only measuring to tenths of grams. And if we did 1.236, that would be even more precise. So the instrument that you're using is going to determine this, but you should always record the measurement as precise as your instrument will allow. Not more precise, don't guess, but do include as much precision as you can in your measurements. And then it's also important to be accurate, and this is determined by you and your instrument. If you have a bad instrument, it can't be correct. It won't measure the correct values. But if you're using it wrong, it also won't measure correct values. So accurate means how close you are to the true value of the measurement you're taking, and for the most part, our instruments are pretty good, but some of them have to be calibrated before we use them. Lots of times with scales, we have to make sure they read 0 when there's no force being applied to them, make sure our balance are balanced when there's nothing sitting on them. So we do have to calibrate our instrument to make sure it's accurate. And then we do multiple trials, which means we measure the same thing more than once to make sure that we get agreement between our measurements. Because if our measurements agree, then we know we're probably making good measurements, and we can average up all of our trials, all of our measurements, to help reduce any errors that might have come from an individual measurement. Now, once we have our measurements made, we actually have to record them somewhere, and we use a data table for that. And when you set up a data table, you need to give it a title, you need to include labels and columns, and you need to put things in their proper spot. So the first column in our data table, remember a column goes up and down, and a row goes side to side. The first column is our independent variable. It's the thing that we're changing, or our manipulated variable. The next 3 or 4 or 5, however many you have, are for the dependent variable, and we have multiple columns for those because we're going to make that measurement multiple times because we want to reduce any errors that we have when we're measuring. We want to make sure we're doing a good job. And then we can use another column to average up all our trials. Remember, when you take an average, you just add up every measurement you have, divide by the total measurement. That's your average. And then we have rows for the changes into our independent variable. So if we had an independent variable, say of length, we could, well, let's actually go ahead and look at an example in a minute. So we put labels and units on everything so we know what our measurements mean, but you don't have to put a unit in every single box. If you just put your unit at the top of the column, that's good enough. So I said our independent variable goes in our first column, so I have independent, but let's say I was changing the length of something to see how that affected the time it took for some other thing to happen, whatever it is. Then I would not write independent, I would write length, and I would not write dependent, I would write time, and length would be measured in probably centimeters, and time would be measured in probably seconds. And then I could say, okay, we're going to use the first length of 10, the next length of 12, the next length of 14, and we're going to measure this and say it took 10.2 seconds, 10.7 seconds, 10.4 seconds. Then I would have all of these measurements and I could average them together and get my final. And so my unit here is seconds, and my final average would be the sum of these 3 things divided by 3, and that would go here. And then I would change to my next length, and I would repeat the process, make 3 more measurements, average it together. And I have my labels at the top of the column instead of at every single row, because then it looks neater and I can clearly see my measurements. Once we have our data, then we actually want to go ahead and use it in a graph to display it in some way. So here's an example data table, and this is for the hypothesis that as age increases, so does shoe size. And so we have years in age over here, 8, 10, 12, 14, 16, 18, 20. So I can see that we measured 8-year-olds, 10-year-olds, 12-year-olds, 14-year-olds, 16, 18, and 20-year-olds. And we measured 3 people from each age division. So there's person 1, which would be like trial 1, person 2, and person 3. And this would be way too small of a sample size to actually get any real data off of. But here it is. And then the average shoe size for that particular age group appears at the end. So the average of 5, 6, and 7 is 6. And I've done that for all of these years. And then we can see there's lots of numbers going on in here, and it's maybe hard to see the trend that's actually happening. And we don't necessarily know, does shoe size go up with age? Well, we don't generally care about individual results, so we're not really going to look at these 3 columns here, our individual trials. We're more interested in the average. So we want to take a look at comparing age to average shoe size. And to do that, we're going to use a line graph. And so graphing data is going to be very important for us. We use basically only line graphs in this class. We might occasionally get a bar chart or a pie chart we have to read, but we're usually interested in looking for relationships between 2 variables. And when we want 2 variables, we want a line graph because we can put 1 variable on the x-axis, which is horizontal. We can put 1 variable on the y-axis, which is vertical, and we can quickly see their relationship. Now, when you have a graph, it should be scaled. That means numbered. And labeled. That means we know which variable is on which axis. So whoever's looking at your graph knows what your data means. And we're going to be making these all the time. I'm going to show you how to sketch them. I'm going to show you how to use your iPad to make them. Remember, always, 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 your independent variable, that's the thing you change, goes on the horizontal axis. Horizontal is the horizon. It goes this way. The dependent variable is going to be on the y-axis, which is the vertical axis. The vertical axis goes up and down, and that's always going to be the case, and we should label each axis with what goes there. So here, I want to sketch a graph of that shoe size versus age graph. And so down here is my independent variable, so that's age, and that's measured in years, and so I'm going to go ahead and put that on my label. And I see over here I've got to go from 8 to 20. 8, 10, 12, 14, 16, 18, 20. That looks pretty good. It matches my data. I'm going to go with that. My shoe size has to go from 6 to 10.5, which is about 5 steps on this graph. And this graph again goes 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go probably by ones here. So I can start down here with 6, 7, 8, 9, 10, 11, and that is going to get me some pretty good data. But I do need to label this, and the unit on this is US because there's different countries that use different shoe sizes, but I put that there. So then I can see at age 8 they have an average shoe size of 6. So I can put that point at 8.6. And then at age 10, 7.5. So 10, 7.5, 12, 9, and then 14 is 10.5, and then 16 is 10.5, and then 18 is 10.5, and then 20 is 10.5. And I don't actually have to connect these dots, but if you want to put in trend lines, you can. And what we instantly see is, yes, as people get older, their shoe size goes up, but only to a point. Eventually, that kind of flattens off. So we can sketch that graph, and it's pretty easy to do. Sometimes it's easier with these numbers. Sometimes it's harder. Sometimes we have to choose our scale a little bit differently. But when you choose a scale, you always have to keep the step constant, which means if this is a difference of 2, it's always a difference of 2. If this is a difference of 1, it's always a difference of 1. I couldn't go 6, 7.5, 9, 10.5. That's not allowed. You can't do that. Every step on the graph needs to represent the same change in measurement. Now there is another way to do this, and we can do this using graphical analysis or Excel, but on the iPad's graphical analysis, pretty good program to use, and I'll show you how to do that. So I'm going to use graphical analysis to show you how to make a graph. So first thing is to launch the app, Graphical, and this is a free app from the App Store. You can go ahead and download it. It's by Vernier, Graphical Analysis. And over here I see the Create Experiment button, and when I push that, down here there is a manual entry selection. I'm going to go ahead and do the manual entry, and that's going to bring me up to a data table that's just blank, X and Y. So I'm going to push and hold on X, and that gives me the option to input new data. So instead of X, I'm going to call this age, and my units are years, and then I can push done. And then I'm going to push and hold on the Y, same thing, and this is shoe size, and these are US shoe sizes, so we'll put in US. And then all I have to do is put in my information. So I grab my data table, and I remember I had age 8, and the average was size 6.
And then I had age 10, average of size 7.5. Age 12, average of 9. Age 14, average of 10.5. Age 16, average of 10.5. Age 17, 18, average of 10.5. And age 20, average of 10.5.
So now I have all my data in there, and I want to actually see the graph. So up here in the top right, there's this window that allows me to pick what I want to see. I want to see one graph. So I choose one graph, and I look at this, and it's not immediately obvious what's going on. But if I double tap in the graph, it auto scales my data, and now I can see right away, oh, there's shoe size. And if I want, I can come down here to this little thing in the bottom left, and I can say, well, let's connect up the points. So it says appearance points. I'm going to do lines or both. I'll choose both. And so I can still see my individual data points, and I can see this. And then I can go ahead and screenshot this or push the little share arrow up in the top in order to get the image and send it to myself or put it in my lab, whatever I want to do.